If you don't do this, then your project will die because it will be too expensive.
First CLT installation was in 2016, and since then, 22 projects and over 2 million square feet of just mass timber. We can do up to 12 stories totally exposed.
There are also some interesting companies that are taking fallen logs from natural disasters, just trying to take it to the next step of how can we be even more sustainable with wood and logs that we're sourcing.
Are there any types of buildings where you think it's going to be very hard or very tricky to build it with timber? Hey guys, I've got a quick request. Could you subscribe, like, and comment if you like the content we're making? It's really important to support the channel and carry on having great guests like we've had. So subscribe, like, comment. Very important. Thank you. Welcome on High Point. I'm pretty happy to have you, especially because there's a lot of things I want to know about from a contractor and specialist in timber. And you're both based in the States, so things must be quite different. But yeah, can I ask you to introduce yourselves? Maybe Dean, you can start.
Sure thing. Dean Lewis, Director of Mass Timber and Prefabrication for Skanska, located in Seattle, and oversee all of our mass timber work across the United States. And then lucky enough to coordinate and correspond with our other teams across the pond on your neck of the woods. And yeah, excited for today's conversation. I'll hand it over to Mark.
Thanks, Dean. Mark Chen, also with Skanska, based in our Seattle office. My title is National Carbon Manager, which means I kind of live in two worlds. One is the corporate emissions reporting world of what we disclose to the Carbon Disclosure Project as a company. So that all goes back to our scopes 1, 2, and 3 emissions for the company itself. And then I also work a lot with our clients around whether it's consulting work or for some of our projects where, you know, we are the GC and the builder, working through sustainability goals and requirements, mainly if it's related to carbon emissions accounting and specifically embodied carbon.
When I did some research about Skanska, obviously I knew what the company was, but with those big companies, there's always things to discover. Can you roughly summarize who Skanska is and what they do, the big, I guess, palette of services and they offer? And not just services.
I'll take it, I guess. Yeah, it's a big question because we do a lot. And me myself, I'm still relatively new to Skanska, just joined in early 2023. Offices all over the world. I guess just focusing on in the States domestically. 3 business units. We have our commercial development team, our civil team, and then our USB team, our buildings team. And within those, the buildings team got 28 offices across the United States, focus on all sectors of the market, mainly civic and public work, do a lot of higher ed, hospitals, and other facilities, industrial facilities, data centers and such. And then within those teams, I think there's different sectors of practice, like me, myself, Mark and his team that focus on sustainability. And so it sets us apart a little bit from other companies that operate in the construction space because we can be vertically integrated as we do our own developments, but then also can do the horizontal piece with our civil team and the vertical piece with our buildings team. And then also in the West Coast, we self-perform the work. So we actually, in Washington, have about 450 craft around there. And then Oregon State, we have another around 400 craft that covers all sectors of construction. And so pretty unique in that aspect that can literally take it from dirt to door. And I think that's what sets us apart a little bit. Mark, what I'd miss?
I guess we should mention we're headquartered in Stockholm, Sweden. Like Dean mentioned, a global company. So it's really interesting to see the different perspectives from our different business units across the world, especially on topics of sustainability, which is, you know, more the world I'm in, but also with mass timber with you, Dean, and some knowledge sharing there.
Are you involved mainly in the States, or are you also involved in projects in other countries, or there's the same roles in different continents or different countries? How is it structured at Skanska?
Yes, for mass timber piece, plenty of work to do just in the States, and more just learning and coordinating with other groups across the pond on what they're doing and what they're seeing, which is interesting because a lot of the same challenges like water mitigation, building remediation, supply chain challenges, and project delivery challenges. But yeah, mostly just focus in the States.
Same for you, Mark, I presume.
Yep, same. Very similar to Dean, just on the sustainability side, of course. So I'm 100% focused on our US projects and corporate emissions reporting. But like Dean said, it runs parallel with mass timber. For sustainability, we have, I would say, quarterly meetings where we will get to discuss certain topics with, our operations in Poland and Finland and Sweden. And it is very interesting to see the similarities in challenges that we see compared to others around the world. So yeah, very, very similar track to mass timber, I would say.
Yeah, I remember when I was at WSP, we used to speak to all the teams, all the different experts in the States or in Sweden or in New Zealand. It was quite nice, this aspect. Obviously, that was mostly on timber because there was a big lack of knowledge and experience. So we had to reach out to our peers in other countries. It was very, very nice. Presumably it's the same for you guys.
Yeah, absolutely. I mean, I feel like we're still in our infancy in terms of timber and getting in these larger buildings and hybrid buildings, what we see a lot. And like I was saying before, I think what's interesting is that this translates over to what we're seeing in Sweden and Norway, the UK, Poland, Czech Republic, where we all have projects that have similar strategies for why they're utilizing timber in terms of sustainability, speed of construction, lightweight nature, the carbon savings like Mark talked about, but then also trying to execute those projects successfully and having that integrated design model, trying to utilize and leverage BIM as much as possible and get all the RFIs and all the pre-planning done beforehand so that everything goes smooth on site. So yeah, it is interesting to just see how other teams are accomplishing it and utilizing different suppliers. But I think the overall methods for success are the same.
What are your responsibilities when do you come on board? I presume pretty early.
Yeah, okay, I'll go first. And then, I definitely want to hear from Mark's standpoint because I think we're both unique in the aspect with our roles. I mean, for me, it depends on the office and the market. So on the West Coast, we can do basically everything from start to finish, and we also self-perform. Outside of the West Coast, essentially still act as GC, but then our knowledge from the self-perform world helps inform and give better understanding for how to approach a project. And so it can be everything from early stage, help with design aspects of the project, how to lay things out, building type considerations, and then getting on board from pre-con and looking at the project delivery method, what suppliers, what installers, what fabricators make sense for the project, given, fiber type, sustainability goals. And then from there, it's looking at, okay, the logistics of the site, where's the crane going to be, trucking, how are we going to bring materials in, what's the layout of the building, how many panels and trucks we got to get in per day. And then looking at going through the actual production and the shop drawings, getting all that on board, making sure that, water mitigation planning, building acclimation is taken care of and contracted with, and then getting everything on site and executing it, documenting it, taking inventory, making sure there's QA, QC procedures, making sure that all the different specifications for product data is followed, and then closing the building out.
I would say almost the exact same thing, pretty broad. I've been included very early on in projects, like Dean mentioned, especially with our Skanska developed projects. I might be in conversations very early on in early concept or even schematic design. And then on the opposite end of the spectrum, I've even been involved with projects months after substantial completion. I'm sure a lot of the sustainability folks know this who are listening, but a lot of the documentation can take you well past even occupancy of the building. So those are the two ends of the spectrum for me. And then there's everything in between. So it really depends. But I'll get involved at the procurement stage when we go to release bid packages, whether it's for concrete or mass timber. I'll be involved oftentimes during construction with some of the documentation reporting during construction, and especially for our corporate reporting, all of that reporting has to do with active projects and whether it's fuel, electricity, or materials purchased, it's all during construction. So I also kind of cover the whole gamut between pre-construction all the way through post-occupancy.
Do you have your subcontractors specialist in timber, or do you have to outsource the specialist, especially on the construction side, so mass timber subcontractors? And I don't know if you know the finances side of it, but how is it easy if you have them in-house? And because you need to stay up to date with the technologies and the techniques, or do you mostly also outsource the specialisms?
Yeah, I think for what we see in the States is a little bit unique, and that's where I go back to the project delivery method. That it varies across the nation. And so, in talking with our European partners, it's interesting there because they see similar struggles sometimes with different specialties, with different materials. For us in the States, though, West Coast, we do see a prominent number of engineers that can design the whole building. They can do the connections, they can do the specialty design. So we're not as concerned about getting somebody on board to maybe do the specialty timber engineering, where more prominent on the East Coast is engineers would do what they call a delegated design, where they might provide loading, they might provide sizing of members, but the connection details are more of a design intent, and they don't have that infinitesimal amount of detail. And so the struggle for us will be sometimes do we get somebody on board that will take that delegated design responsibility, and then talking to the owner about when to contract them on and what the scope is, and negotiating that with the engineer of record and making sure that it's very straightforward, because it can get a little convoluted. Connections is one thing, but the diaphragm design, the transfer of loads from the floor plate into the lateral system, making sure that that's all very clear. So that's part of the process, I think, that needs to be taken into consideration in terms of specialists. We do have architects and engineers on staff. It's more for review purposes, or getting called in to review special load conditions or something like that. But we don't contract it out internally. We go to third-party specialists for that delegated design.
I will say on the subcontractor side, whether it's sustainability or mass timber or whatever topic it might be, there's always the challenge of making sure we are aligned with our subcontractors who are actually installing the material. So, but that's a whole nother kind of rabbit hole.
Yeah. An ongoing discussion on the podcast is getting the subcontractors on board as early as possible. And there's different different barriers of doing this, and there's different it's not always the same responsible for it, but it's very hard to convince, let's say, I'm not going to stigmatize it, but the client side, to convince them to spend more money, to have a look and say, if you do this now, you'll spend less money, far less money later down the line. So I'm speaking from my point of view. If you, for very specialist buildings or very high-end buildings, if you don't consider the acoustics, or if you don't have an experienced acoustic consultant on board from the start, you're very likely to increase the costs. And I can understand it's very hard to convince a client to spend more money on this, but sometimes it's so important, because if you don't do this, then your project will die because it will be too expensive. And I say this because we've just been working on an arena, and in timber, it ended up being very, very expensive, but we came on board far too late. There's so much experience you need to get to start those buildings and make them come to life, that sometimes it could be really hard to outsource or to have the expertise in-house, because there's not that many really big pure specialists in the topic. But yeah, I don't know what's your experience. If you've got any experience with acoustics, that'd be quite interesting.
Yeah, I think in the States, for instance, with acoustics, it was there was a real struggle, especially early days, and just kind of a misunderstanding, because timber's a lot lighter than the other building materials that we work with. And then there's also not everyone wants to expose it. So there's just not a resilient break between the assembly. And so we had, the tried and true is kind of the gypcrete or cementitious topping with a acoustic mat and CLT. And a lot of the acoustic mats in the early days were, very thin layers like we would typically see in our light frame construction. So they weren't providing that resilient break to get the impact insulation class that we really needed. And so there was a struggle to, okay, how are we going to design this residential building? Or a lot of the early projects were office and higher ed, and creating an echo chamber, because there just wasn't enough buildup to provide the level of performance that we needed. And so then, coming to more recent times where there's been a lot of entities that are products that have helped develop this, both on, I think, kind of the concrete and gypcrete side, as well as the acoustic mat side. A lot of research done by Woodworks and Softwood Lumber Board. FP Innovations have done a lot of research, and then suppliers going out and doing their own research, their own testing. And then universities getting involved. I know University of Oregon and OSU with the Tallwood Institute, they're building a new test chamber for acoustics in the States, which is going to be huge, because even though Woodworks has a compilation, an index of over 100 assemblies on their website. It's amazing that we'll get on a project and you'd think you got everything figured out, and then all of a sudden you want to hit a specific rating. And it's a very, like, back to your point, Mark, of, fine tuning that assembly, because all of a sudden you're influencing the weight, which can in turn influence the floor assembly from, a fiber standpoint. You kick it up from a, 6 7/8 inch 5-ply to a 7.5 inch 5-ply. And that has impacts on not just the amount of fiber, but the overall floor to floor, your weight. It's cascading. So yeah, acoustics can be really important early on.
Unrelated, but tangentially related to mass timber, we've also seen just product selection be affected by acoustics, which then potentially impacts the sustainability side with embodied carbon. We've seen, projects where we wanted to use a more lightweight gypsum wallboard product, but that didn't, the specs of that product, while lower on embodied carbon, didn't meet the acoustical design criteria. So we had to go back to the drawing board and figure that out, just as far as finding a product that can meet both requirements. And like Dean was saying, in this particular example, we were in construction as we were evaluating that change. So, of course, as everyone knows, it's always tougher the further you get into construction with those kinds of things. So definitely agree that going through those exercises and identifying those issues early on is very important, especially with things, people don't usually think of sustainability and acoustics as having a lot of overlap, but we've actually seen, in that particular example, some really strong examples of where the acoustics and the sustainability goals we have to make sure we're coordinating between the two.
A lot of the time it goes both ways. Acoustics is just not sustainable at all. Because you add mass, you add rubber, polyurethane, metal sometimes.
You could say that about a lot of things in construction, right? So it's all part of the challenge.
Yeah, obviously, from my point of view, I feel very guilty about this, and we're trying to change, but sometimes it's inevitable. What's your view on mass timber? There's loads of solutions coming up, and when I say mass timber, it can be panelized timber options like with straw, with dense wood fiber. Have you got any data that shows that there's some solutions that are very efficient in terms of cost and have a pretty good embodied carbon quantities or rates? Have you got any data on this, and that you should obviously not avoid some materials, but that some structures will work really well and they're either the future or the existing realities that you need to carry on doing or using?
Yeah, I think maybe I'll start on the mass timber side, but then turn it over to Mark to talk about the carbon standpoint, because that's something he's been looking at. For us, it depends on the project. That's the political and popular answer. But for us, I think, Skanska is interesting because we were born out of a concrete company. And so timber's absolutely something that's not new for us. We've been building with it in Sweden for decades. And then here in the States, we've been building with it since the early 2000s. And first CLT installation was in 2016. And since then have, 22 projects, and over 2 million square feet of just mass timber. And what we're seeing now, which is interesting, is the new codes that have been adopted here in the United States, which allow us to go up to 8 to 18 stories. And even the newer code cycles, which have been adopted in states like Oregon and Washington, where we can do up to 12 stories totally exposed. Kind of a game changer, which Mark can touch on as well as the carbon standpoint, because it's less gypsum that we're putting on the product for passive fire protection. It also reduces the speed or increases the speed of construction, and also enhances the biofield benefits. But in terms of your question about cost, I think what's interesting for us on the West Coast in a seismic region, and there's seismicity specifications from the code that are going to increase the forces on buildings. And there's a couple emblematic effects in materials codes as well. But what that means is that essentially timber buildings are going to have an inherent advantage being more lightweight. And so what we're seeing is bigger advantages for buildings in that 12 to 18 story range, not just from a foundation standpoint, but also from just a lateral systems standpoint, and in terms of comparing to concrete or steel. And so it's going to make things really interesting. Typically, how we try and measure it is we look at the square footage, we look at the piece count, and we look at the cubic footage per square foot, try and bring down the amount of fiber to make the building as most efficient as possible, still meeting the code requirements of having like a 2-hour rated frame. I think if you're in the West Coast in a seismic region, there's definitely a case. But then there's also been projects that we've done over on the East Coast where almost the whole project is mass timber, and you're limiting the amount of hybrid nature to it. That's like our Cincinnati Public Radio project that was just completed this past year. That whole building, there's only about 4 pieces of steel in the stairs and elevator shafts. Everything else is timber. And when you have a building like that can go up in just a few weeks, and the walls are finished, and basically all you got to do is the curtain wall. I mean, that's an extremely efficient build. And so it goes back to the statement that it kind of depends. But inherently also, I think the carbon is something that we're hearing a lot more about from owners, which is really exciting. And we're seeing in specifications. And I know Mark can talk about that more.
Yep. The carbon side of wood and mass timber. It's, so I'll try and paint the picture as best I can. So, like Dean's saying, we've had a number of projects now where we've looked at, okay, what's an embodied carbon emissions, so everything that is related to the raw material extraction, the manufacturing of construction materials, getting those materials to the job site, installing those materials on the job site. We have in the past on projects seen good benefits for that, purely the upfront embodied carbon impact of mass timber versus, a comparable steel or concrete structure. So that benefit is purely on, if you're not even considering the carbon, so, trees naturally sequester and capture carbon throughout their lifetime. There's then that carbon dioxide you've captured from the air that's essentially locked into the wood. So all of that, and then also the carbon that the tree is then during its lifetime either capturing the wood and or keeping in the soils of where the tree is located. There's lots of interesting science rabbit holes to go down. So that carbon dioxide is known as biogenic carbon. And so a lot of people will point to the fact that mass timber and wood, of course, naturally has that biogenic carbon benefit of these trees are sequestering and capturing carbon throughout their lifetime. I will say on the actual carbon accounting side, for what's, again, that biogenic carbon, it is still a hotly debated topic. And so to round out what I'm trying to say here is, even if you take out that biogenic carbon factor of what's captured within the tree, because the issue then becomes like, what are you making an assumption for the end of life of the building? Because someone, 30 years down the road could demolish the building, send that mass timber product to, a waste to energy center where it gets incinerated into energy, and then you've just re-released all that carbon. Again, this is why it gets so complicated with wood. So I'm just going to say we're going to take that out of the equation for now, because it necessitates a whole nother 1 hour long podcast.
Happy to do another episode if you want, or part 2 of it.
Yeah. Man, you could, yeah, there's a whole nother world with biogenic carbon. But if we're taking that out of the equation, we're still seeing a good potential reduction in embodied carbon emissions for mass timber compared to steel or concrete. But that's, again, only if you're looking at the upfront embodied carbon emissions. You still need to consider what's going to happen during the life of the building as well as the end of life. But it's been really interesting to look at that across different structure types, and also going back to the biogenic carbon conversation, really get a feel for some of the challenges that you would think would be benefits on the wood side.
What do you see the most promising mass timber, I guess, panelized or volumetric elements or engineered options? And my question comes from, in the episode with Lowry, Tulberg kind of said that CLT has had a hype, but now we know it's pretty expensive. And therefore, there needs to be some alternatives that are coming up. And obviously, I mentioned one of them with Eco Cocoon, but there's many others. I don't want to just mention this one. There's also L'Eco Labs based in Luxembourg who do great stuff as well. And there's loads of other panelized options. But let's talk about panelized options and maybe alternatives to CLT first. What do you see coming up as really promising, economic-wise and carbon-wise as well?
Yeah, I mean, this is something. It's a good comment, because while CLT is amazing and it's been great to get codified and take us from 8 to 18 stories, because I mean it's a large achievement, because you got to have something that's can take seismic, have a 2-hour fire rating, be a beautiful product, be able to be repaired, take construction, egress and water and all this stuff. And so I think those are all the considerations in evaluating new products, which will come on the market, as we get through kind of this first phase of adoption, because we're still early days, I feel like, because the first PRG 320 was out in 2012. We're only 13 years in, and we just got the code changed in the last couple of years, and it's been adopted. But as we're talking about new products, I do think what's interesting and exciting, looking out and seeing what some Europeans are doing. Also what we looked at doing in the States, and looking at like cassette floors. And what excites me is trying to do like a stress skin panel or a cassette floor that's made up of smaller elements that utilize a more efficient layout of wood, and then insulating that maybe with like a wood fiber insulation to sequester more carbon, also benefit from an acoustical standpoint, but then also get longer spans, maintain the same fire rating, and also be able to act as a diaphragm for seismic. And so those are some of the things that have been looking at with Mark and his team on how to enhance the carbon story for a product just beyond just the timber component. Look at insulations, look at the acoustical mats, and look at all these other products that we can additively make the best product possible.
As far as new products, and this has been in lockstep with Dean, but there are also some interesting companies that are trying to make timber even more sustainable, just from not a feedstock, but I guess you can call it a lamb stock for like CLT and mass timber, of taking, fallen logs from natural disasters or municipal maintenance, land clearing for a development, just trying to take it to the next step of how can we be even more sustainable with the actual wood and logs that we're sourcing. So that's, I let Dean do all the research when it comes to innovative new products just on the actual system side. I'm always closely following, the sourcing of the wood, and again, innovative companies that are really pushing the envelope on where we get our logs and our wood from for mass timber products, because then that, of course, is directly correlated with the carbon benefit, but also other sustainability benefits outside of just carbon.
There's other options I really like that integrate a lot of other stuff. And obviously, I completely forgot to mention Ligno Trends and Lignator, who are German ones, but maybe you've had a look at them. They're really interesting because they not only integrate the structural side of it, but they integrate the acoustics, and not just the sound insulation, but they come ready-made with impact sound insulation and sound absorption at the bottom, well, on the underside. Have you ever investigated this? And obviously they're all timber, so it's perfect. And a lot of them, some of them don't use wood fiber. They use more, I guess, less sustainable insulation. But I don't know if you've got similar products or options like this.
Yeah, Lignator is pretty interesting. Keelstig is another one that's pretty interesting in terms of utilizing, less wood fiber in a more efficient manner. Different considerations for fire, that's for sure. But Lignator is interesting because of those acoustical panels on the bottom. And we see a lot of that actually on our school projects, office projects. We actually do a lot of that acoustical wood paneling that looks exactly like that, but it's additive. It's like a hung ceiling, like an ACT ceiling that we'll see and have come in and is costly. So then it begs the question of, could we have something like that built in? Or we see a lot of projects where we use dowel laminated timber, mostly from Structure Craft, and they have their own acoustical panels that they utilize, and that's the acoustics is actually built into the panel. And so it's kudos to them and their ingenuity to come up with that system that has now been deployed on many projects across the United States. But then we have, a handful of projects coming up where that is being specified by the architect because it's both, the biophilic aspect of it. You got the carbon aspect of it with timber, but then also because of the acoustical properties on the underside of the panel that are inherently built in.
What's your experience on the cost of this? Obviously, it will depend on where the product comes from and where it's produced. Is it more cost-effective to have a prefab option or build on site? Especially if you have all your in-house specialists to know how to install their products on site.
No, I'll try and get to that though, because I think it is a good question. And what I think about often with comparing price for mass timber is that you're not comparing, the same thing in terms of building types. And for your question, I think what depends is like the overall end quality that you're looking for, because you're going to have higher quality for sure. And you're going to be able to ensure that quality through prefab. Typically with prefab, try and go for at least cost parity to make sure it's the cost equivalent. And sometimes you have to prove that out with an enhanced schedule. And that's most of the time, that's kind of what we have to do. And maybe there's a cost advantage to it, given that it's going to be higher quality and you'll be able to ensure that, and it's going to give you an accelerated schedule. Because I know we had a project recently, it was higher ed. It was a good sized project. And for the first time, the owner was really asking the question of, how much does these two buildings cost? We're comparing a steel and a timber building, but they didn't want the timber or steel building to look like a steel building. You're going to build this steel building, now I want you to wrap, all the steel columns and timber. You're going to wrap all the steel beams, or you're going to have a drop ceiling. And so all of a sudden, you're basically recreating the same building, but you're building a steel building and making it look timber versus just a timber building. And all of a sudden, the timber building starts to become very cost advantageous because, to your point, Mark, you're going to have to go back and add in all these wraps, add in all these drop ceilings. And that's not conducive for many reasons. Sequencing, thinking about having a stage, the different subs coming in and going through the building, it's just really inefficient.
There's a really interesting site. The company is called Situ, CITU, and I really like their model, what they're doing. They're based in North Yorkshire. They've got two different sites, and I've seen the site in Leeds. And they basically have a factory where they bring all the materials, and they've got massive sites where they've built gradually their houses, and they use obviously prefab options, but they build everything, all the panelized options in this case, and assemble everything in the factory and bring it to the site, or bringing exactly where the house needs to be. I think they were also going to do a school at some point. So because if they have all those houses, they need to provide for a school options. But have you ever had a look at this in the States? this option? I guess it's more you need to have a developer hat as well on this.
Yeah, I mean, I've looked into panelized solutions versus volumetric pretty heavily. Early in my career, worked with different companies, and I think panelized has the advantage of more flexibility for building types, smaller scale production sites. You don't have to have a huge facility like you do with modular. Modular, you have to have really focus on your backlog and keeping that factory moving because you have such a more robust, operation that you got to keep moving to keep the money flowing. Where panelized, a lot of the shops that I've visited or seen, you can have a smaller facility that can produce a lot of product. And then from a cost standpoint, I think, definitely I've worked with modular companies where you're able to reduce costs greatly. If you're like in a hotel or residential situation, affordable housing, did a lot of those projects when I was down in the Bay Area, and it's a turnkey operation, where they're shipping those modules to site and you are, not having to open the door, and it's got everything in there from beds. It just doesn't have the bed sheets on it, So those operations can be very efficient, but it takes, again, the right client and the right backlog, because you always hear about, modular companies that are really successful for a few years and then it drops out because they have to just basically survive that market cycle and make sure that their backlog can be consistent, or else if they can't feed the factory consistently, then it can be problematic. And then similar to prefab, but more efficient for shipping, especially with prefab as well, and componentized walls and floors. Did a lot of prefab floors and walls in the Bay Area as well. And that can be an efficient system and more flexibility. You're not depending on, modularizing the unit layouts of the building and controlling the unit layout of the room itself. So more flexibility for those systems.
I've got a question for Mark, mainly on sustainability. Obviously, acousticians need to add mass, and usually mass means unsustainable to me, but it's changing. Because if you need to add mass, you need to add plasterboard, you need to add concrete, you need to add a lot of really dense materials and bricks and stuff like this, masonry. What do you see as the really good mass alternatives and with low embodied carbon?
It always depends on the material. And I would say for your point, Mark, so yeah, I acknowledge that acoustical design might result in additional material, but again, so could a lot of other things. Like Dean mentioned, seismic in the West Coast, there's lots of drivers that add material to a project and add mass. What I will say is that when we do get to that point where that's necessary, we can look at the available data. So Skanska co-developed what's known as the EC3 tool, which I think is becoming an industry standard as far as procurement level embodied carbon analysis. So it's a tool that allows you to look at manufacturer to manufacturer, product to product, the available options from an embodied carbon perspective. So yeah, Mark, to your example, let's say we're looking at an acoustical underlayment of some kind, or again, that going back to that gypsum wallboard example, once we've locked in and once we know that that material is needed, we can at least look at product to product, which one is performing best on carbon. So that would be how we approach it, because, of course, we're not acoustical designers, so we're going to control what we control as a builder, which is where we source our product from, of course, in conjunction with our design teams. So I would say that's the approach. And again, the EC3 tool is that the tool we use to do that evaluation. And it's also, as far as creating a market signal and moving the market, just having access to that data and being able to communicate that data to our suppliers and manufacturers. So again, using the acoustical underlayment as an example, let's say we have manufacturer A at this emissions intensity for their underlayment product compared to manufacturer B. And let's say manufacturer A is vastly outperforming manufacturer B on that same product, but on the carbon side, we have then the ability not only to recommend that manufacturer, but also communicate those results to both. And that's what really creates good market competition. And again, sends that market signal to these manufacturers that carbon is now one of many additional criteria that we're looking at when it comes to sourcing. Yeah, there's always going to be situations where you just can't get out of certain materials and adding in mass, like you were saying, but we still have steps we can take to really look at our procurement process to try and make, the most well-informed option or decision.
So what's this tool called?
It is called the EC3 tool. So it stands for the Embodied Carbon in Construction Calculator tool. It's a free open source tool, so anyone with an internet connection can access it. Essentially what it is, it's a big digital repository for environmental product declaration data, EPD data. So that's what allows us to then look at that EPD data and be able to determine, in some cases, product or manufacturer to manufacturer, what the embodied carbon performance of different scenarios might be.
I'll have to have a look at it. It's quite interesting because I think I mentioned it to you, Dean. So we've launched a new company. It's official now. Today, it's online and it's called the Acoustic Design Library. It's a branch of Atelier Crescendo, and the Acoustic Design Library is focused on education, so explaining about more about acoustics. But there's a big part of it that started it, which is the Acoustic Design Catalog, which we created to find more acoustic products and sustainable ones. But so when I speak to architects and contractors, obviously, and QSs as well, quantity surveyors, there's a big question mark on products, the best ones, discovering some that are not really known because they've not had a really good, big marketing budget, but it's something we're building up and trying very slowly, but we want some feedback. And that sort of feedback you just gave is quite important to be able to source, to be in touch with some manufacturers and suppliers and have the embodied carbon data and be able to compare that and establish what is the best one. And obviously we don't want to make it a marketplace. Maybe it's going to become a marketplace at some point. I don't think it's the ambition. The ambition is more to have access and awareness of some solutions. But it sounds really interesting what you say, and it seems like we're going in the right direction.
Yeah, I think an interesting segue on that too, and Mark can probably touch on this, is we're seeing other state and municipality codes, like for instance, like Cal Green, I know, has a new initiative, and I can't remember the exact square footage, but it's like school or state-funded projects. If there's commercial buildings, I believe over 100,000 square feet, they need to follow certain prescriptions. They can either reuse a certain portion of the structure. They have to complete a whole building life cycle analysis and either show that they can reduce the embodied carbon by 10%, which is a low barometer for now, but it's starting and building to, better standards. But then in the end is a prescriptive portion where you can also basically use EPDs and show that your materials, steel and the facade and the concrete are on average lower than a specified threshold that the municipality regulates. And so, the EC3 tool and your tool, Mark, for acoustic products are key to that because, if companies that's kind of the easy button, is doing the prescriptive analysis and just saying, okay, we're going to use these products to reduce the potential global warming for the project. But if not, then they're going to have to go to greater measures, right? And show that through whole building life cycle analysis, they can reduce the carbon by 10%. And so that's in California. We're seeing other initiatives kind of coming up in Boston. And Mark, I know there's other cities that you probably are in touch with that are doing similar measures.
Yeah, lots of city and state level policy making around embodied carbon. But yeah, Mark, it's interesting that you bring up the word marketplace because I always think of EC3 as our kind of carbon supermarket, if you want to call it that, because those EPDs are like your nutrition fact labels for your products, similar to how you would go to the grocery store and look at your nutrition fact labels on your food. But now it's got me thinking, like, this would take you would have to start a whole nother business around this.
We have competitors, not necessarily on acoustics. It would be amazing if you could have everything as well documented technically for a lot of different disciplines. And I guess it's a challenge. The reason why we thought the catalog would be really good is because I don't believe there's that many competitors who are really focused on acoustics. I think it would be a reference for people who want to know more about acoustics, but how about fire? because they will also have a fire requirement. So will we have to integrate some fire technicalities? Obviously, if we want to do it as engineers, we want to do it properly, technically. But there's also the thermal aspect, the structural aspect to it. So is there a big market? Probably. It's going to be very hard to do. And that's our question. How do we build it? Do we need, at the moment, we're bootstrapping everything. So we're not getting any investments. But hey, there's AI and AI agents. And we're already, so it's a chat we had with some of the previous guests who haven't, the episode hasn't been released. It's crazy, not just AI, but AI agents, what the capability of what you can do. And one person can work for 10 people.
Mark always needed a clone. There we go.
Are you, well, yeah, on the AI topic, are you looking at AI stuff at all? Or?
Yes, and it's more for, I'll say yes in the sense, so this is now going into our corporate emissions reporting world. So as you can imagine, when it comes to reporting our fuels and electricity and material purchasing and even business travel as a company, it's a lot of data to sift through. So we are looking at how AI could assist with that. That way, like, I don't need to go through 200 different fuel invoices on a quarterly basis for what we're, purchasing at our job sites across the country, and just utilizing AI to do that, grunt busy work. So we have looked at it on the sustainability side in that scenario. But, of course, there's all kinds of different use cases for AI, and I'm still trying to educate myself on how that all works, because I want to tread carefully with the AI as far as what it's being used for, right? So anyways, but yes, we have looked at it and the potential of AI for certain applications within sustainability.
Yeah, I think from my standpoint, I know on our operations side, we definitely use AI. We have Microsoft Copilot, and we can essentially we use it a lot for contracts or specifications. We can basically, data dump, and that's one of the benefits of Skanska, is obviously leveraging the power of all the projects and all the resources that we have as people across the company and look into something. And for instance, I know we were building it out when I first started, and I remember, typing into our AI chatbot, what are the lessons learned on moisture mitigation for mass timber? And initially it came back and there was almost nothing. It was like a sentence or two, basically like temporary protection and this and that. And a year later, after we had kept uploading all the documents to the server, came back and typed the same question, and it had like 10 bullet points, very concise, very specific recommendations on sealers and, temporary membranes and, temporary wall systems and all this stuff. And so I think, it is a great tool, and especially for us, there's a popular saying in Skanska, and this might get edited out, but yeah, if only Skanska knew what Skanska knows. And that's why I feel like AI comes in handy, because it's able to sift through all this data to make sure like we have all the resources at our fingertips, but it's just having the knowledge to know what options are even available and then what option to use. So I think it's a great tool for that.
What we found on the AI topic is really interesting. The obviously it's very trendy. It's very cool to talk about AI, to look at AI. But what we found is that obviously the LLMs, so large language models like ChatGPT, DeepSeek, and blah, blah, they are fed a lot of data and they will make assumptions. So obviously sometimes they can hallucinate. And what we found, especially for the library, is that you can't take something technical and ask them to spit something out. You have to feed them with the exact data. But you can feed them with really raw and ugly data, and they will obviously present it very well or recap it very well. So that's the capability. You can actually use it in the States. So ChatGPT has released Operator. I think it's called Operator. You can basically ask ChatGPT to take control of your browser, internet, and do a task for you. So if you want a t-shirt from whatever shop that's black and it's running t-shirt in this size, it will put everything, it will look for the website, look for the t-shirt and put it in your basket. And when it's ready to be paid, they will ask to just pay. put your card details. If you think about it, it's absolutely crazy the time you can gain from doing this. And I'm not going to say give any details in public, but I can tell you again next week what we can do and the time we can gain from doing this for our own use. Obviously, it's really at its infancy, but you can get all the AIs to communicate with one another to have a really detailed answer. It's crazy. Obviously, you need to have some different steps of like control steps where you need to be able to control what they're doing because they can go crazy.
You don't want to give it your credit card. Just have it go crazy. Get all the Christmas shopping done, and you get a bill at the end. But yeah.
Yeah, I was going to say that's trouble for people who have a little bit of an online shopping addiction.
One quick question that Larry Toolberg said didn't believe in robotics and 3D printing houses in concrete. What's your view on this?
I mean, I know I got mine, but I want to hear Mark's as well because I think there's a place for every product, and 3D printing is being utilized pretty heavily on smaller residential buildings. I think for large scale buildings, there'll need to be a little bit more innovation, like multi-story buildings. I think it's done 1 and 2 story dwellings. I don't know if there's been structures that have been 3D printed without additional formwork and additional measures. Like I know there's other printing machines that have been used with concrete. So I don't know about not believing in it. I think it's, like I said, every innovation has its space. I mean, it's construction. It's a multi-trillion-dollar industry and it's being ready to be disrupted. And I think in the right place, in the right time, 3D printing concrete can, definitely be suitable. So
what are the alternatives to concrete?
So you're saying lower carbon or more sustainable types of concrete? Yeah. That's a whole, there's a lot of fascinating work being done on that topic. For concrete, for the most part, it's how do you really decarbonize cement production? Because that's as far as what concrete's made of, the highest impact material within concrete. So there's lots of kind of market-ready solutions right now where cement producers are doing a lot of great work around introducing lower carbon cement alternatives to the market. But there's also kind of that next step of innovation and really pushing the envelope where, we're looking at everything from, taking post-consumer glass and using that as what's known as recycled glass pozzolans in concrete to replace cement. Which also, of course, has a dual benefit of you're creating a recycling market for, depending on where you're at in the US, a material that doesn't have a great recycling market. And then also using that to replace a very highly carbon intensive material, Portland cement. So there's, innovations like that. There are all kinds of other companies. We have our whole like matrix and table of all these different really cement producers that are trying to kind of hack the way cement is made so that it can be lower carbon, which then equates to lower carbon concrete. And it's a combination of looking at the technology of how you turn a raw material into a cement, or even finding a new feedstock for cement, because feedstock currently for cement is mainly limestone. So it's what other naturally occurring materials can you find where you can then incorporate that into a different process to then create an equivalent cement product. So there's a lot of really interesting and encouraging work happening on the concrete side.
Yeah, interesting. Obviously, we all love timber. We all love bio-based materials, but sometimes you have to use concrete. And I don't want to win it out of the equation. Obviously, we know how bad it is for the environment, but sometimes it's unavoidable. Are there any types of buildings where you think it's going to be very hard or very tricky to build it with timber? Or for certain aspects? Maybe not just buildings, but infrastructures, bridges, tunnels. It's more in that realm. Are there any like red lights flashing when you see a certain type of building for timber?
You brought up a good one. I would say, long spanning tunnels. That would be one where I'm like, that's probably not the best use. Even though I do know in Switzerland there is a partial tunnel built out of timber, which I can send you afterwards, which is pretty awesome. It's got 2 arches that have a road that spans over and it forms a tunnel. So it can be done. And it's those trips. And I think there's a trip I did up to Vancouver, Canada, BC, that I did in 2012. And that was really eye opening because back then, they had their first CLT supplier in Structurlam, and they were producing all types of structures. They had done fire stations, and they had done cogen facility that they had done, and beyond, hotels and residences and, higher end buildings. They were basically just doing everything that you could imagine. They have their light rail stations up there that they have mass timber structures. And so I know Sound Transit here in Seattle has taken inspiration from that. Now they're looking to do it. So I don't know if there's a categorical building type that can't be done. The red lights would definitely go off for long spanning tunnels, underground tunnels. I think that would, maybe not be the best use, but I think that's the fun part about timber right now is there's so many innovations that are still forthcoming, and the supply chain still growing, that can hopefully help out with, the price point and bring it down a little bit more and help it be more cost competitive to help then proliferate it. We're also seeing, I think what's interesting is large tech companies that are utilizing timber for fulfillment centers. That's happening right now in the States, and also data centers, which is really interesting because these companies, and so definitely interested to look at different solutions for that, because there's optimizing the overall frame itself. And I know Mark has thoughts on this too, because we've looked at, okay, what's the structure itself that we can use to optimize it and make it timber? There's also the racks that we can utilize timber for, which has a whole nother level of implications. And then also, like Mark can talk about the concrete, using different types of insulation and really enhance to make data centers much more sustainable than they are traditionally built right now.
Which, if you really zoom out, we were talking about AI a lot earlier. And so, that AI technology is also necessitating, new data center builds. So it's an interesting, in sustainability, to look at it from the very high level of, the push and pull of different technologies and innovations, and then what the, downstream effects are. So,
Dean, I saw that you had some experience working with Sidewalks.
Sidewalk Labs. Yeah, that's right. Yep.
And I used to go on the website quite often, and I like the idea. Are you able to share a bit of experience on what you did there and what they do for people who don't know about it?
Yeah, Sidewalk Labs was an offshoot from Alphabet, and basically focused on bringing innovation to the built environment. And so they had several different companies which had innovations for, digital electricity. There was automated parking and transportation, and there was systems for helping optimize MEP usage in buildings, retrofitting buildings. And then our sector, the one that I had joined, was called Canopy. And it was focused on basically a prefabricated kit apart system with mass timber. And going back to what we talked about before, we had a cassette floor. We also had a prefabricated wall system, which was passive house rated. And then we also had a timber frame, which had a proprietary glued and rod connection system. The idea was to have this prefabricated system that could build, 30-story towers, just really massive buildings. And the first project was Quayside over in Toronto, which unfortunately didn't work out. And then the company shifted from a project view standpoint to a product view standpoint. And so we started focusing on, okay, how do we productize, buildings and make them repeatable and help utilize our kit apart systems to basically make it very efficient from both, a carbon standpoint and a structural standpoint, but also an energy standpoint. Because where we saw the building codes going, especially up here in the Pacific Northwest, and you see it out in Boston as well, and other cold weather climates, is if we can enhance the envelope of the building and get a building to passive house standards, then the energy optimization for the lifespan of the building has much farther implications than just, tweaking an MEP system. And so that was kind of where we saw environmentally where things are going, not just for cold weather climates, but also hot weather climates. And so, that was part of the journey and the adventure. Worked with a lot of extremely talented and smart individuals, but unfortunately our runway ran out when the VC market dried up right in the midst of COVID. So, yeah.
On reuse and recycling materials, it's a pretty hot topic at the moment. There's quite a few challenges with thinking about acoustics, reusing acoustic materials. What are your views on it and how you can reuse building materials from a contractor point of view? What are the main challenges?
Yeah, I'll go first, and then I'd like to hear Mark's thoughts because he has a wider view on overall materials. For me, with timber, I mean, obviously reuse is something that's critical and has a cost component to it. And there's companies in the States that are trying to specialize in this, like Urban Machine and Cambium and others that are trying to actually recycle wood or used wood from fallen trees. And then there's also the aspect of designing for disassembly, which Mark hit on earlier about biogenic carbon and looking at the life cycle of a building. And a lot of these buildings, what's really funny is when you come to the conference here in a week, what I love to show is you talk about design for disassembly. You have, all these companies that are building like 2-story structures in a day or 2 days. And then at the end of the conference, they're disassembling them, putting them back in a truck and shipping them back to, their facilities. And so, these buildings can be disassembled, and there's actual testing that's going on now. And the USDA has a grant out for this and essentially showing the case and standpoint that, these building elements, these large sections of engineered wood lumber can be repurposed into other buildings. And we actually did some of that at Sidewalk as well. I know Holmes has done some research on that, Structure Craft and their facility. They did a facility out in DC that's designed for this. And so that's really, something to consider, at least from a timber standpoint. But I know Mark has more to consider for other materials as well.
Yeah, I was going to say every material has its own unique set of challenges when it comes to reuse and circularity. But, it usually all boils down to a lot of what Dean talked about in the same general concepts and challenges. So it's, yes, can you deconstruct and salvage the material in a cost-effective and relatively non-invasive way? There's also kind of in the midterm between actual reuse, identifying a product and then actually getting it specified and included in a new project. There's that window of time in between where you have to figure out what are you going to do with that material. So oftentimes we either have to figure out storage, other logistical considerations like that, right? Because a lot of the times we might have certain elements of an existing building that we salvage and that are valuable and that we can re-include into a new project. But, we might, salvage some old brick or, some mass timber elements from an existing building, let's say 30 years down the road. But, we're not going to be reinstalling that material for another year, 2 years even sometimes. So it's who owns the storage of that material, and especially for like wood, keeps it in a somewhat conditioned environment so that, you're not subjecting it to the elements over the course of a year or two. And then, of course, it's also coordinating with your design team to evaluate, okay, where can these salvaged materials be incorporated into the new design? Because there's, of course, limitations to that, just with the quality of the existing material, its inherent material characteristics. And of course, it's a very, the path, there's a fork in the road of if you're going to use it purely for architectural purposes or if it'll be even like a structural application. There's a whole host of more considerations there. So there's certainly challenges, but I enjoy reuse and circularity and waste because it opens the door for a lot of creativity, but then also a lot of like interesting storytelling and potentially community building and things outside of just carbon, right? Because, carbon's important, but it's not everything. I think the circularity piece, it can appeal to a wide audience because, whether you care about it from an aesthetics perspective, whether you care about it from avoiding sending material to landfill, whether you care about, in some cases, saving costs, and you can hit kind of all those things. So circulator is really interesting in that sense.
Is it more economical to recycle products? To me, it sounds, first thought is yes. but then maybe there's a whole bunch of costs associated to it that I don't know about.
Like Dean said before, it depends. I mean, I'll give you an example of why it depends. Because if we're just talking about pure recycling, we've seen like good economics with recycling, especially for a product like steel, because steel has a really, from a recycling commodity perspective, really good value. So it's usually cheaper for us to recycle steel than it is to send it to a landfill. But in that scenario, you might be able to, like for that earlier example, just demolish a building without carefully deconstructing it. If you want to actually reuse steel and say, you have a large steel beam that you want to deconstruct, salvage, and then reuse in a new project, there's, more potential challenges there from a cost perspective, because it's, until we have some kind of technological breakthrough, it's still faster and easier to just demolish a building rather than, deconstruct it piece by piece. So there are some costs for that approach of actual reuse and salvaging materials. But a lot of times the recycling, especially as we start to see more higher landfill rates from municipalities, I think the recycling economics a lot of times can work out pretty well. But again, it depends on the material. But with actual reuse and deconstruction and salvaging materials, a lot of your costs are more on the logistical side of like, how do you actually salvage this material in a way that's usable later by another user?
I'd be really interested to hear about if there's anybody listening to the episode here who are specialists in or know about recycling mineral wool or fiberglass, because it sounds like it's so heavily used that you could easily... I don't think it would require any heat to recycle. You could reprocess it in some ways. Maybe not.
One other company to check out there is Wood HP. They have a facility out in Maine, and they recycle their own product, and any offcuts from the timber bat or that they use, they can produce. They produce like a rigid panel, and any offcuts from that, they didn't put that into their timber bat.
Is that wood HP or timber HP, Dean?
Timber HP. Yeah.
I think this is something we're going to be more and more interested in. We're really interested in, at the moment, we're focused on paving slabs, reclaimed paving slabs, concrete paving slabs, because when it started with using it for gyms, so obviously sometimes you need a floating floor for a gym because you need to control the vibration transmitted, especially from the free weights. So you put things on isolators, fairly heavy and dense floor, floating floor on an isolator. And the heavier, the better. But the question is around, can we actually not use concrete, but we use reclaimed paving slabs, like concrete ones that are really heavy? I've got some in my garden, they're crazy heavy, so I'm sure they would work really well. And you sandwich them in plywood or more like any rigid materials, and what can it do? Obviously, it could crack, but maybe we don't care about it cracking. So that's our focus. But there's also the whole question around, if we reuse an acoustic material, how can you recertify it? Make sure, prove to a specifier or a designer, an acoustic designer, that it will achieve what they're expecting. And that's the whole challenge, because also on a logistics point of view, but on a cost point of view, because acoustic tests are really expensive. I don't know if you've got any comments on this, but it's really far down the line. Obviously, acoustics is always late to the game, I find.
Yeah, and I mean, that material testing can be a big deal. So I mentioned structure, but also acoustics. So I haven't seen that use case before in that specific scenario. It's certainly, I have to think from a pure material cost perspective, it's got to be probably competitive. But yeah, then you have to factor in the logistics and the testing. The additional kind of design and coordination time you have to spend to figure that out compared to your, standard cast in place concrete slab or whatever might be going in there otherwise. So,
well, it's been great talking to you both. And
you as well, Mark.
I'll see you soon, Dean, and maybe another time, Mark.
Yeah, absolutely. Thanks for having us on. It was fun.
Yeah, thank you, Mark.